Artificial intelligence is rapidly transforming diagnostic decision making in modern healthcare. But how does it compare to traditional data analysis techniques such as logistic regression, classification trees, or manual interpretations? Here we explore AI-based traditional data analysis and discover who truly best for the diagnostic accuracy. Traditional analysis like logistic regression and classical statistical modeling has been the foundation of diagnostic research for decades. AI models, especially machine learning and deep learning, have recently shown superior performance in complex dataset, especially imaging. What is traditional data analysis? Traditional analysis uses hypothesis based modeling, regression techniques, limited predictor interactions, requires assumptions, normality, linearity, independence. Advantages included interpretability, simplicity, and reproducibility. What is artificial intelligence based analysis? Artificial intelligence uses machine learning, support vector machine, deep learning, convolutional neural network, recurrent neural network, and transformers. Features learning from large datasets, non-linear patterns, and high-dimensional data. AI learns directly from data without strict statistical assumptions. Diagnostic accuracy metrics. To compare both approaches, we use sensitivity, specificity, accuracy, precision, and recall. Rogue analysis area under the curve. These metrics help identify which model performs better in real world diagnostics. Traditional data methods strengths transparent interpretations, good for small data sets, statistically rigorous, works well for structured data. For example, logistic regression predicting risk of health diseases. AI methods strengths excellent for large datasets, automatically extracts features, better performance in imaging and genomics. Models complex non-linear relationships, for example, CNNs diagnosing lung nodules from CT scans. Calculate diagnostic accuracy with AI. Calculating data diagnostic accuracy with AI involves training a machine learning or deep learning model on a labeled medical dataset and then evaluating its performance using established statistical metrics. The key is to compare the AI model's predictions against a ground truth, the actual diagnostic confirmed by the reliable methods such as a biopsy, lab results, or expert consensus. Evidence from research. AI outperforming radiologists in image classification. Machine learning improving early sepsis detections. Deep learning achieving higher area under the curve in cancer diagnosis compared to logistic regression. However, traditional statistics remain strong in small sample clinical data sets. AI use in real world. Examples where AI wins. Radiology, X-ray, CT, MRI interpretations, dermatology, skin lesion detection, pathology, digital slide analysis, ECG and wearable device analysis. Example where traditional methods still dominate clinical risk scoring, small cohort observational data, laboratory based diagnostic cutoffs. Who wins? There is no single winner. AI wins when datasets are large, complex, and image based. Traditional analysis win when sample size is small and interpretability is essential. Hybrid models. Combining both approaches may provide the best diagnostic accuracy. Feature The future is shifting towards explainable AI, integrating AI with clinical judgment, real time decision support, hybrid AI statistics models. We conclude AI is shaping the future of diagnostic research, but both AI and traditional statistical methods have their own strengths. Understanding when and how to apply each method is the key strategic to improving diagnostic accuracy. Thank you.
Please subscribe and like our channel and press bell icon for more videos.